Alright, so we're in geometry, we're in the right triangle unit. And you can see here at Algebra Geometry SOLG 0.8, the student will solve real world problems involving right triangles by using Pythagorean Theorem and its converse, properties of special right triangles, and right triangle trigonometry. So today we're going to start with Pythagorean Theorem and its converse. So we are on day 1, so we're on Unit 8, Lesson 1, and the notes for Unit 8, Lesson 1 are right here, and the workbook problems are on page 124, 1 through 6, and 18 through 27. Let's go ahead and get into this. Pythagorean theorem is something you've had before. Essentially, the Pythagorean theorem says in a right triangle, the sum of the square of the measures of the legs equals the sum of the square of the measure of the hypotenuse. Okay. Or essentially, a squared plus b squared equals c squared. Like I've said in the past, you guys have done this in probably middle school, and really should be something that's kind of review. The part that students get confused on is for number 1, you do a squared plus b squared equals c squared. So you're going to square these and add them. But number 2, if you have the hypotenuse, you square the numbers and then subtract the squares. Okay? And so we want to make sure we keep that straight. So I'm going to go ahead and pause the video. I want you to go ahead and do 1 through 7. I will tell you, like in 6 and 7, you either have to add to the picture or draw a picture. So the triangle is here, and this is a length of 11. So you'll know how much this is, and you'll know how much this is, and then you can find that. Number 5, obviously x is the same as x over here, and then number 7, you have a square with a perimeter of 16. I'm not going to go over that right now, but you should know what that means. And then it wants to know how long this is. So when you do these, obviously you got 7 squared plus 3 squared is equal to x squared. Well, 7 squared is 49, 3 squared is 9, so you get 58 is equal to x squared. And we've talked about how you take the square root of that in the last chapter, and we've talked about it in other chapters in geometry. So again, you're going to go to y equals, you're going to go to 58 divided by x squared. You hit second graph. And square root of 58 does not reduce. So I can either say the square root of 58, or if I do the decimal, it'll be 7.62. On number 2, I can do 7 squared plus x squared equals 10 squared. 49 plus x squared equals 100. So x squared equals 51. And when you do the square root of 51, square root of 51 doesn't reduce. Or you can say 7.14. Make sure you understand how to do both. Okay. So go ahead and finish 3 through 7. Pause the video. And when you're done with those, I'm going to go over the correct answers. Okay, so for number 3, and you probably had a question about this, 4 squared plus 4 square root of 3 squared. You notice 4 squared is 16, and I have 48 here. Now, if you did it in your calculator and you did 4 square root of 3 squared, you got 12, because there's not a second set of parentheses there. Okay, so I broke it into pieces, and I have 4 square root of 3, and then I square that answer, and I get my 48. And then the square root of 64 is 8. Number 4, a squared plus 8 squared equals x squared. 128 equals x squared. X is equal to 8 squared root of 2, or 11.31. Number 5, 15 squared minus 12 squared equals 81. X is equal to 9. Number 6, if this length is 5 and the whole length is 11, then this length is 6. This length is 8 because it's 8 over here. So 8 squared plus 6 squared equals x squared. X equals 10. Square of the perimeter is 16. That means each side is 4. So 4 squared plus 4 squared equals x squared. X is equal to 4 times square root of 2, or 5.65. Again, make sure that you use the correct formula of, a squared plus b squared equals c squared. And then just, obviously things that are true are going to be true. And also, make sure your answer makes sense. So like here, I got 10. Well, this is the hypotenuse. The hypotenuse is always the longest side. So if I would have gotten an answer like 4, and I would have tried to say x is 4, or around there, well, that doesn't make sense. So again, make sure your answer makes sense. Make sure you look at the picture, and if you are finding the hypotenuse, it should be the longest side. If you're finding one of the legs, it should be less than the hypotenuse. So that'll help you do problems 1 through 6 in the workbook. We also have to know the converse of the Pythagorean theorem. So if the sum of the squares of the measures of two sides of a triangle equal the square of the measure of the third side, then the triangle is a right triangle. A Pythagorean triple is 3 whole numbers that satisfy the equation a squared plus b squared equals c squared, where c is the biggest number. Now, you remember in the last chapter, last unit, we put, okay, is 6 plus 8 greater than 10? Well, that's how you tell whether or not something's a triangle. If I want to know if it's a right triangle, I have to do 6 squared plus 8 squared, and that has to be equal to 10 squared. Well, 6 squared is 36, 8 squared is 64. Is that equal to 100? Well, 36 plus 64 is equal to 100. So not only is this a triangle, but it's a right triangle. All of these will make a triangle. That's the whole point. Like, these are lengths of triangles. However, do they make a right triangle? So go ahead and check 2, 3, 4, and 5. Again, remember, if you're going to use this one, you have to use 2 sets of parentheses, or just do 4 square root of 3 and then square it to get your final deal there. So go ahead and do those, and we'll pause after the video and check. Okay, so 11 squared plus 11 squared equals 15 squared. You add those two together, doesn't work. 4 square root of 3 plus 4, 48 plus 16 equals 64. That's good. 81 plus 81 equals 225. No. 33 plus 44 squared equals 3025. 55 squared equals 3025. That's good. Okay, so here's how we can use this information. And this is your leftover work. So I've already went over how on page 203 you're supposed to complete 1 through 6. Okay, and so that's just do you know how to use Pythagorean theorem? 18 through 27. So what it wants to know is, what's the third number that would make this a Pythagorean triple? Well, you can try 2 things. I'm going to do number 18 with you. You can say 13 squared plus 84 squared equals, and then take the square root of that. So we're going to go to calculator here. And I'm going to hit the square root of that number. All right, I got 85. So it's 85 squared. If I wouldn't have gotten a whole number there, I could have done 84 squared minus 13 squared and try to do the square root of that number. And I don't get a whole number there. So, I could have put 82.98, but that would have been a little bit difficult to do. So anyway, you can either add or subtract to find the third number that will go to make a Pythagorean triple. So here it's 85. In 24 through 27, you're just checking, just like we did in the workbook, just like we did on the notes, is this a right triangle? So is 18 squared plus 19 squared equal to 27 squared? If it is, then it's a right triangle. Is 11 squared plus 11 squared equal to 11 squared or 3 squared? If it is, it's a right triangle. If it's not, it's not. So you got 4 of these to check. Just by looking, I think 2 are and 2 aren't. So, you know, that's something to guide you there. All right, once you're done with these 16 problems, check them off with me, and then we'll get started on the next unit, next lesson in the unit.